We've got a action-packed sort of hour here. I think I timed it out, and I've got about 45 minutes of demos. So we'll try to be quick with the intros and other things and get right into it. And we should have some questions at the end as well for you guys, and we'll answer as many of those questions as we can. We've got a pretty large group, it looks like. So we will get into it. All right. So like I said, this is presented by Wintelect. In addition to webinars like this, we also offer consulting, training, both in person, if you want that, as well as online virtual training. And we are planning sort of a more in-depth, deeper dive of virtual training on this topic next month. And I'll mention about that again at the end. So if you get to the end of this webinar and you think, well, that was really great, but I really want a little more, and there's some things that we're just not going to have time to get to. And so if you're interested in that, I would encourage you to definitely consider that virtual training that we're going to do a little bit later. It'll probably be 2 days in length, and we'll have plenty of time to really dig in and go deep on some of this stuff. We also have some on-demand virtual training as well, video-based training via Wintelect now. So, great. For me, I first started doing software back on one of these back in around 1982 or so. I've been kind of along the ride ever since, and been doing Microsoft .NET type stuff since the very beginning. So a few things for Rocks Press and some stuff for MSDN Magazine. And most of my time now is with the latest and greatest new stuff, which is usually the Xamarin things or with ASP .NET Core. And being cross-platform, that opens up a lot of really great stuff and works really, really well with Docker. They're sort of made for each other, as we'll see here with some of the demos. So I'm going to go through the agenda here, and while I do that, do have a couple of just some quick poll questions for you guys, just to get sort of an idea where everybody's at. So first one, just how familiar you are with Docker, and then we'll also see where everybody sits with ASP NET Core. So our agenda today, we are going to cover a little bit of Docker essentials. So just so we're all on the same page as far as terminology and some of the commands we're going to be using. There are a lot of great tutorials out there about sort of doing your hello world type stuff with Docker. So we're going to try to go through that as fast as we can. We just want to make sure everybody's, like I said, on the same page when we talk about what an image is versus what a container is and so forth. So I'm looking at the poll now, and I see that about almost 30% of folks say they're not familiar at all with Docker, and so that's good because we'll take care of those essentials, and we should be in a good place. About 40% or so, here I can put the results up here actually, about 42% say you basically know what it is but haven't really used it much, and then it goes from there, and pretty much nobody is actually using it currently for production work, and so that's great. That's kind of what this webinar was designed for. As far as skill level from you guys. So let me go ahead and pop the other one up here. So how familiar you are with ASP NET Core. So once we get through some of the Docker essentials, we will do an example that's a little more interesting than Hello World. I'm actually going to show running SQL Server 2017 in a Docker container in Linux on a Mac, just to be, something cool. We'll talk about why that could be handy, but we'll do that. And then we'll jump into specifically ASP.NET Core with Docker. So we'll create an ASP.NET Core web application. We'll deploy that to a Docker container. We'll actually push it to a registry, and we'll run it somewhere else, maybe over on the Mac side. And then we will also talk about some of the new stuff in Visual Studio 2017 when it comes to debugging. And we'll look at how we can actually debug code running in a container and see how that works. And then some about deployment as well. So once you've got your code running in your container, how we can get that up to a hosting provider like Amazon Web Services or Microsoft Azure. And so we'll look at both of those as much time as we have. That'll be near the end, but I will show you an application that I have that's actually running in AWS as a Docker container, and then we'll set something up in Azure too, and we'll look at that. And then, like I said, we'll try to have some time for Q&A there at the end. So if you'd like to type some questions into the interface there and go to webinar, you're free to do that, but we'll save them until the very, very end. So once we get to the end, I'll scroll down the list and I'll see what questions folks have asked, and we'll see how many we can get through. All right? Okay. So our poll here about ASP NET Core. So a few people not all familiar with it, but most folks are, so that's really good. That some people are So we're not going to talk a lot about ASP NET Core. This is more focused on sort of how we can get our core application running over there. But again, in the 2-day virtual class that we'll do next month, it'll be much heavier on sort of how ASP NET Core works and how you can adjust things and make it work better with Docker. So that's really good. All right. And almost 20% of people using it for production work. That's excellent. All right. Cool. Okay. So I'm actually going to turn off my webcam now because we'd like to have as much horsepower available as possible for our actual demos and things. And so we'll do that. Okay. Cool. I do want to point out a GitHub URL here. And so it's up on the screen right now, which is this github.com/Wintellect webinars. And I will also put that URL in the chat window. So it'll be a little easier if you want to click on it or what have you. And if you were to go there, you would see a page that looks something like this. And so this is where we post material for the webinars that we do. And so we do have one in there right now, which is our ASP NET Core with Docker. And in there, I've got some prerequisites as far as what you'd need to install if you wanted to do some of the demos the way that I'm going to do them today. Some links on the bottom that we're going to come across during the course of the webinar. And then in the demos folder, because a lot of our demos are going to involve a lot of typing at the command line, I've put in here the commands that I'm typing. So that way, if you'd like to try to do these demos on your own at some point later, you can go here and then you don't have to furiously try to write down the commands as you see them in the video. So I wanted to just mention that, point that out there. Okay. All right. So Docker Essentials. Docker is basically a software container platform. And so you can look at Docker from lots of different perspectives. You know, why is it good for a DevOps type person? Why is it good for an administrator? Or why is it good for a developer? And so since this is ASP.NET Core and Docker, we look at it from the developer perspective. And really, when it comes down to it at the end of the day, Docker helps us to eliminate some of those works on my machine kinds of problems, right? As a developer, we always like for our development environment to be as close as possible to the end production environment. As soon as the more differences you have, the more chance there's going to be that, you know, cannot duplicate closed ticket type thing, which is never fun to do, right? And so Docker's going to help us with that, and we'll see how that goes. Automating the setup of development and deployment environments. So the way that we can deploy our code when we're testing it and when we're actually developing it and debugging it is identical to where it gets sent to QA, staging, production, all the way down the line. So you basically pick up the entire application with everything it needs, from our perspective, the entire OS in effect, and then carry that along its way. One of the best quotes I heard about this was that it sort of allows us to treat our instances, our actual, you know, hardware instances on AWS or Azure or wherever, less like pets and more like cattle. So if you're in a VM type scenario, usually what you end up doing is you create your virtual machine in the cloud, and then it's like your pet. You know, you give it a name, you have to make sure and feed it from time to time, and, you know, install updates so it keeps running, and make sure you don't leave it alone for too long because bad things could happen, that sort of thing. Where with Docker, we want our instances just to come and go as needed. So fire up a new one, put the container on that. If it has a problem, we'll just let it go away. We'll fire up another one, put the container on that. And if we can have something that can do that for us automatically, monitor the health of our instances, things like that, that's great. So that's what it really is all about. So when somebody says that Docker is a container platform, the next question that typically comes up is, you know, what's a container? So we're going to do some demos and things, and we'll get a feel for it. But basically, it's just an encapsulation of your application with all of its dependencies. And so if those dependencies mean other things that need to be installed on the box in addition to your application, it carries all that stuff with it. That could be something like Redis or SQL Server or whatever, right? And if you have multiple containers running on the same physical machine, they actually share the same OS kernel. So when we compare, for example, a container versus virtual machines, and you see this type of graphic on the web out there because it's the most common question that usually comes up with Docker is, how is this different than a VM? Well, with VMs, you know, you're basically carrying the entire machine up into the cloud, right? So it includes your app, it includes all the binaries and libraries that it uses, it includes the entire guest OS. So then if you, say, deploy another version of your app, you either can replace the app on your existing virtual machine, or you could create a whole new virtual machine and maybe push that up there, right? A whole new image or something. But virtual machines are very heavy, right? They're big. They take a long time to sort of launch up and start. Where in a container type scenario, we have the Docker engine that has the ability to run these different containers. So yes, there's still the host OS. You see it in the picture there on the left, but the host OS only exists sort of once. The Docker engine is there, and then we can have our different binaries, libraries, and then our code and our application sharing that same sort of kernel. So in other words, they start and stop very quickly, but from our application's point of view, it still sort of looks like it's a whole entire machine all to itself. And so we will talk a little bit about how that works, but you know, as much time as we have. But as we'll see, when we go to create a new one, start it up, shut it down, it's very, very quick, right? Much different than a VM. I've actually come across people that have used Docker in a web type application where every request that comes in, a new container is actually started to process that request, and then the container goes away. Next request comes in, a new container is started to process that request, and then it goes away. That's a bit extreme and probably not something you do, but it does just illustrate the fact that in difference in sort of the performance and how heavyweight they are. Imagine starting a brand new VM for every request that comes in, right? Yeah. So the Docker platform and its associated tools and things are available on lots of different platforms, and we're actually going to be flipping back and forth between two of them. It's going to make it really easy to sort of download and build and test and run our containers. So if you go to Docker's website, you know, you can pick your platform, get what you need, and install it. So if we're in the case of, here I am on the Mac, and so I have Docker installed on here, and so up in my notification area, I've got my nice little Docker icon there. It says it's running, and this is where I can manage things about the engine itself. And sometimes this is necessary. So for example, one of the demos we're going to do here in a bit is with SQL Server, and SQL Server happens to require more memory than what the Docker engine allocates by default. And so you may have to up this a little bit. If I'm over on Windows, same sort of thing. Here's Docker down here, and there it is. And I've got the same settings. The window looks a little different, but it's all the same stuff. All right. And so I can very easily take a container that I created on one, move it over to the other, run it over there. It's really nice. So if I'm over here on the Mac for a second, I'm going to go ahead and say Docker version. And this will show me what version I'm actually running the tools on, which of course is the Mac, and which version of the OS I'm using to actually run my containers. So I actually have a sort of instance of Linux here that that's going to run my containers for me. Okay. So for example, if I'm deploying to AWS, I've got actual EC2 instances that are running. Each one of those is running the Docker engine, and then each one then has the ability to run containers. Each one may run one container. Each one could run 10 containers. It's sort of up to you. By the way, this experimental true, I've got that question before. All that is do you want to have access to sort of the experimental features that are available? And you can uncheck the box if you want, but it's not that this is a beta version or something like that. It's just that they keep adding new stuff, and so do you want to have access to that experimental stuff at the command line in the tools or not? You know, you get to pick. If I flip over here to Windows for a second, and we'll do Docker version on Windows, similar thing, but now my client is actually running on Windows, so I'm running my tool on, but my server is still Linux because I have the ability to run Linux containers over here on Windows. Now, one of the interesting things about Docker on Windows is I could come down here and actually switch to Windows containers. Windows containers are relatively new versus Linux-based ones, but by doing that, I now have the ability to run containers that are based on Windows. So a Docker container that uses Windows Nano or Server Core, things like that, right? And so as an ASP .NET Core developer, we actually do have a choice. We could run ASP .NET Core app on a Linux instance, or we could run it on Nano or Server Core or full Windows or IIS or not IIS, or you get a lot of choices, right? And so now some of the support we'll see later for Windows containers is still evolving a little bit, especially with Visual Studio, but you do sort of have those options. But a lot of things are going to be the same regardless. So when we're talking about Docker, we have images. And a container is really a running instance of an image. Okay, so your image is basically, think of it as like a VM image, for example, and then you launch it, it's running, all right? what makes Docker sort of interesting is images are built up from layers. Okay, and some of this gets into some of the behind the scenes, which you're not exposed to a lot, but it's good to know a little bit of what's going on. Is that when you have a Docker image, it starts with some sort of base layer, which is usually some sort of operating system, Debian or CentOS or whatever it happens to be. And then there's modifications are made to that base image. So additional things are installed, say the .NET runtime components. So now you have an image that's made up of 2 layers, the base OS plus this extra stuff that's Microsoft installed on it, for example. And then you go ahead and you can create your own image from that one. So you're adding another layer on top, which contains all your application's code. So that means that when you go to deploy for the first time, yes, you will need to copy the entire image up to AWS or Azure or something. But then when you make changes to your app and then you go to deploy the changes, you only need to deploy that top layer because the other bottom layers are already there. All right. Now, the reason that can work is because every layer below the top layer is read-only. You can't make changes to it. You say, wait a minute, no, you can't make changes to anything that's below the top layer where my code is? Well, you can, but what Docker employs is sort of a copy on write system that you can have many, many different containers that can share the bottom layers, but if one of those containers goes to modify something at one of those lower layers, a copy is made, and that copy lives at the top layer. And so now you're working with the copy that you have up at that top layer. So the bottom layers are never actually modified, but to the application code, it kind of looks like they are, right? It's just making copies when it needs to for the parts that you're modifying. So that works out really well. And we'll see that too when we go to like pull down new images from some place like Docker Hub. We may not have to pull everything because we've already got, a lot of layers. So for example, if I've got 10 images that are all based on CentOS, I only need those bottom CentOS layer one time, and it's shared across all of them. So when you view your images in Docker and you see this one takes 500 meg, this one takes 500 meg, this one takes 500, they're not actually taking all that space because they're probably sharing layers between them. And it works really nice and it's very transparent to you, but that's a little bit what's going on there, right? So container registries exist, and so these are places where images are typically stored. And then you can push them up there, you can pull them down. Docker Hub is one. We're going to do a demo with that coming up. But you can also, AWS has their own container registry. Azure has their own container registry. There's others out there. And there's a concept, kind of like GitHub, right, where you can have public registries and private ones. So if you're pushing and pulling from a private registry, you need username, password, that sort of thing. Where the public registry, anybody can pull from it. So we'll see that. So getting an image, you can either pull an image from a registry explicitly, or if you just tell Docker to run an image, it'll go ahead and just pull it if it needs it, which is kind of what's shown on the slide here, but we'll do it in just one second. So the first one, I actually say Docker pull Debian. Debian is just the name of the image on Docker Hub. If I was pulling from some other registry like Azure or something, I'd need a fully qualified sort of URL in there, right? But if it's just the name, it assumes Docker Hub. Pulls it down, I've got it. In the bottom one, I'm actually just saying to run a new container from the Debian image and then telling it to echo out hello world or something, right? In that case, it may say, well, I don't have that image, let me go pull it down, pulls it down, then runs it, all right? So containers can, and we're going to do that again in just a second, but containers can be run interactively, so you can launch them and then have a command prompt, you do stuff with them, or as a background process, like for example, an ASP .NET Core web app would run as sort of an ongoing process that would be listening on a port. And then at some point you can shut that down, but by default it just sits there and runs as long as you want it to run, okay? Containers, think of containers as sort of like process-based in a way, in that you usually create a container and then you specify the main process that container is supposed to run. And when that main process exits, the container exits, stops, right? This sort of makes sense for an ASP.NET web app because we want the container to launch and then run the .NET executable with my ASP NET Core DLL and then just keep on running, listening on that port. And if that process ends and quits, well, then the whole container should just go away. And if I want it again later, I'll launch a new container. All right, again, we'll see that. That works pretty good. So let's jump in and do some stuff because that's enough slides for now, right? All right, so I'm going to come over here and I'm going to do a couple things. Just again, so we're all on the same page of what's going on, and then we'll jump over to Visual Studio and we'll do some stuff over there. So first thing is I want to view the images that are on my machine right now. So I have one, which is the Microsoft MS SQL Server on Linux image, and I pulled that down already because you can see it's sort of big. over a gigabyte here, the total image with all of its layers. By the way, if you want to sort of see, get a better view at sort of the layers that are there, you can actually do that as well. Whoops, 59. And you can kind of see these are the layers that were built up. And so Microsoft started with a base image, and then they put some more stuff on that. You can see some calls to apt-get, for example, installing some additional things. And so if I create my own image from this image, it would be basically adding another layer on top of the stack, right? All right, so what I'm going to do is I'm going to go ahead and explicitly pull the Debian image from Docker Hub, all right? And so it's just going to go out there and get whatever layers it needs. If it has to get them all, it gets them all. If it doesn't need a couple of them, it'll just tell me it already has those layers. And then I'll have a image, and I'll go look at it. Now I got two images. I got the Debian image, and I got the Microsoft SQL Server one. So what I'll then do is I'll say, well, let's go ahead and run this guy. Now when I run an image, like I said, I can do it interactively, or I can run it as a background sort of thing. But I'm going to say interactively and attach a terminal. And again, on the Docker website, there's really good documentation of all these commands. Now, when I specify an image, I can just say Debian here, or you notice up in the list, there's an image ID, and it looks like that's A25C1EE. Kind of nice thing about Docker is I can just specify enough of the image ID so that it doesn't conflict with any other ones. So I only have one image that starts with A, so I could just say that, and that'll actually work. And so now I'm in my Docker container, and there we go. It's an instance of Linux, basically what it looks like to me. There's all my directories and what have you. I'm in my prompt in my container. And so I want to open another window here, and what I want to do over here is I'm actually going to say Docker PS to show me all the containers that are currently running. And so there it is, and it's been up for 19 seconds. And so I'm going to come back over here now, and let's do something fun. Let's go ahead and make a directory called test on this image. And so now I have an additional directory called test. And then what I'm going to do is I'm going to exit. So now I'm out of the container, back to my regular prompt. Now, if I look at the containers that are currently running, I don't have any. But I could say, well, show me all of them, and then it shows me that that container is actually in the stopped mode. So it's there, it's just stopped. And so what I could then do real quick here is I could create another image from this one, give it a different name. And so I've just created a new Docker image called testing, which is basically started with the Debian instance, but then it has that modified directory that I added. Okay, and so now what I could say is, well, let's go ahead and run that one. I'm going to run it interactive. It's okay to just remove that thing when it exits. So I don't want it to go to sort of the stopped state. When it goes stopped, just delete the thing. Okay, because if I need it again later, I'll just start it again later, right? And so I'm going to start my testing one here. And so now I'm in my testing image, and it's running. And yeah, there's my test directory. So nice. All right, let me exit out of that. And now if I look at Docker PSA, just that first one is there. The one I just, because I said it could remove it once it was finished executing. Now another thing you may do with Docker is you might just sort of say, well, I have a Docker image that I'm going to use to perform a particular task. So we'll say Docker run, remove it when you're done, use the Debian image, and what I want you to do is echo out hello world. So it's going to launch a container from that image, do that sort of work, that task, and when that work is finished, the task finishes, container will stop and then just be deleted. All right, so I'm just using it to perform some sort of action or function. Okay, and again, if it's in the case of an ASP NET Core app, it would just sit there listening on a port for however long I want it to be there. Okay, but this guy is, nothing's running now. Okay, so yeah, so let's do something just a little more interesting. Like I said, is we talked about the container engine a little bit, and so Linux containers can run on Linux, Mac OS, Windows. Windows containers can really only run on Windows because it uses some of the infrastructure that's provided in Windows to be able to run those. So you can't, for example, run a Windows container on a non-Windows platform. But now, SQL Server via Docker. So let's say I'm a ASP NET Core developer, but I really like doing my work on a Mac for whatever reason. Okay, so I've got Visual Studio for Mac now that just released not too long ago as part of it was announced during the build conference. And so I can use VS Code or I can use all sorts of different IDEs, but I like living over here on the Mac. And so as I start doing that, I realize that I have a lot of things that I would expect to be there, like the debugger works and a lot of other features that are coming in here, like source control and IntelliSense and all those things. But then when I'm developing my ASP .NET Core app, I'm used to using local DB over on Windows to do my local database development. Now, when I go to production, I probably use SQL Server in the cloud or something on Azure or whatever. But for local development, I really like having that local SQL Server database that I can use. Well, over here on the Mac, I don't have local DB, but that's okay. Docker can solve that problem because I can basically run full SQL Server in a Docker container on my Mac and then connect to it in Visual Studio for Mac and basically use my application. Right? So I want to kind of show what that looked like real quick. And so I've already done my Docker pull of that image. Okay, so that image, by the way, let me jump over here. Over here on Docker Hub, here's the home of Microsoft on Docker Hub. So these are all the different Docker images that Microsoft officially sort of provides and supports. So here's the Microsoft MS SQL Server Linux one, and it'll give you some details about this image and how to use it and so forth. So in here it says, for example, to start an instance, here's the run command. And you need to put some things in here like, an environment variable that says I accept the EULA and the password for the SA account and so forth, right? So, okay, so I look at that and I figure it out. I know which one I need. I pull it down, so I've already got it here. And so now what I'm going to do is I'm just going to go ahead and run the Docker command to run or to start a new container using that image. So it's the same as what I just showed on the web page here. I give this container a name, so I'm going to call it localDB because that's sort of what I'm used to from Windows. Specify these environment variables that are required and a port number. So that's what the P option here is SQL Server runs on port 1433, so I want to expose that internal container port outside so that I can get to it from my Mac, right? So I'm just going to push it straight through. I could specify a different port if I wanted to, and then which image to use when starting this container, right? So I'm going to go and do that. And you notice how fast that was. That was kind of nice. So, yep, there it is running. And so now what I should be able to do is just use whatever tool I want to connect to SQL Server. So I could use Visual Studio. I could use, Management Studio. I don't have Management Studio over here, but I've got sort of something on the Mac which is close to that. So here I'm connecting to 127.0.0.1, port 1433. So this is my container that's running on my machine. I can connect to this thing. And now maybe let's create a new database called, test or something. And so I just create a new database here, and then I could maybe, create a new table or something called testing. And so I got a table, and so now what I'm going to do is I'm just going to close this guy down for a second. And I'll show you one other thing that's kind of neat. This image is still running now, but I've just created a database and a table, and I can connect to it. So I can go to Visual Studio and put in a connection string into my app settings or something, be able to connect to it. But over here in Docker, I can also open up a nice little GUI application that's included with the Docker tools called Kitematic, and this provides a nice little GUI. And so you can it's showing this local DB here that's running, and now I can actually see the container logs, which is pretty neat. So this is messages from SQL Server that it created my database and it's up and running and everything's great. Or I can even click on the exec here. There's a way to do this a command line, but it's nice to just launch that from the GUI. And now I'm actually at the command line in my instance that's running SQL Server. So for example, I could say I happen to know the directory, so I could maybe go take a peek. That there's the actual SQL Server database file. So there's my test MDF that it created. Whoa. All right, so jump out of there. That's interesting. But now what I could do is I could come over here and I could stop this instance. So we could say docker stop, specify my container here. So 52 is good enough, container ID. It'll stop that instance. Takes a couple seconds, shut it down, whatever. Because what I want to show is I want to show that we can stop this instance and then we can restart it later, and then my changes will still be there, all right? Because I'm not deleting it. So if I do PS, nothing's running, but it's there. It's in sort of the stop state, as well as that other one that I did earlier. And so now what I'll do is I'll say, all right, let's start that guy up again. All right, so now it's running again. So now I should be able to go back over to my SQL tool here and reconnect to it, and then yeah, everything's still there. So that's pretty neat. Okay. Now, if I was to actually remove that container or delete it, well then sure, it's gone. And if I start a new one from the image, well, I got a new one from the image, right? All my data and stuff will be gone, but I can start and stop it all I want. So that's pretty nice. Okay, so just a quick little example there of using SQL Server. Now, one thing I did have to do in Docker, I mentioned it earlier, but I did have to adjust the memory to make sure I had enough, but it's also talked about in the page on Docker Hub that you need to do that. Okay, and I could do the same thing on Windows and run SQL Server in a Docker container on Windows or Linux or anything, anywhere I want that can run the Docker engine. Okay? And it's going to be exactly the same on any platform, wherever I run it, because I'm sitting on top of the Docker engine, which provides that isolation. Right? Okay, so what next? Well, let me get back to the slides here for a second. So really great for development and testing. Typically not the best choice to do something like run SQL Server in a Docker container in a production environment. You could, but usually, your database, because it has this persistent data that you want to keep all the time, you're probably going to be using something more like I said before, SQL Server in Azure, or sort of the data services are provided by AWS or whatever it happens to be. Because, like we said before, we like Docker because it allows us to treat the entire instance as cattle instead of pets, right? So they can come and go and as we want. So, and it's also something you need to think about for things like logging, for example. If you've got a bunch of Docker containers running in a cluster, you want those things to just come and go as needed. One's not healthy, shut it down, bring up another one. Well, if you're writing log files to the local disk on that thing, when that gets shut down and you launch a new one, okay, that's gone, right? So you need to have your logging being pushed off to somewhere else, right? Some other machine where that's being recorded, a cloud-based logging solution, something, okay, to do that. All right, so SQL Server on Docker. Now, this webinar is titled ASP .NET Core with Docker, so we want to get into that, okay? And so we've got some .NET Core images that are provided by Microsoft. One of them is just Microsoft/.NET, and this would be for running, .NET workloads. There are different variants of this, so let's take a look here. If I go back to the Microsoft list, and I look at now notice there's ASP.NET, there's ASP NET Core Build, so here's Nano Server. This is the base image for running Nano Server. Here's the base image for Windows Server Core. We got another one called ASP NET Core, and so there's also one that's just called .NET. And so this includes images for both .NET Core on Debian 8 or Jessie, as well as Nano Server. And then they have different versions, and they also have different, we'll call them variants. So this is about you choosing which base image am I going to start with here. So for example, when we get down into the list here where it talks about variants, it says, well, any one of these that ends with SDK includes the compiler and the command line tools and everything. So you can use this, for example, to create a build server as a Docker container. We have another one that doesn't have SDK on the end, but has runtime. So this has everything you need to be able to execute your code that you can deploy your web app to, and it'll run there, but doesn't include the compiler and all the other tools, right? And then we have another one called runtime deps. It says this image contains the operating system with all of the native dependencies needed by .NET Core, but doesn't actually include the .NET Core runtime components. So this would be one that you'd use if you were creating a self-contained deployment from Visual Studio, for example. Right, so you don't actually need the runtime there because your application's carrying all that with it, right? Just depending on how you're doing your deployment. So it's a matter of just picking, all right, which one of these do I want? Am I making a build server? Am I, publishing from Visual Studio and deploying that? Am I doing a self-contained deployment? You have to decide which is the one you want. It talks a little bit more about that down here too. Okay. All right. We also have a Microsoft ASP NET Core set of images. And so this adds some native images for all the ASP.NET Core libraries to basically make things a little bit faster because it can use those. There's also another one called the Microsoft ASP.NET Core Build that includes the ASP.NET Core stuff, plus, again, all of the command line tools, SDK tools, includes Node.js, Bower, Gulp, because if you're going to use it as a build server, you may be using something like Gulp or Bower or whatever to manage your client-side dependencies and things. So you need to have those on your build server. So again, it's a matter of picking sort of which image. If I go back to the sort of the website here, And just really quick here, take a look at the ASP NET Core one. There's also ASP NET, and that's for full framework stuff, not core, right? But if I go to the ASP NET Core one, same thing. It's got versions here that are based on Debian as well as on Nano Server. Even got the 2.0 preview stuff in here as well if you wanted to play around with that. Another great thing about Docker, if you want to play with some pre-release stuff, beta or alpha or preview, whatever, I can just run that stuff in a Docker container and not have to sort of pollute my machine with a bunch of preview versions of different things. Right? And so that's pretty slick. All right, so what I'm going to do is going to go build an ASP NET Core app, and we'll start talking about things in there. Before I do, though, I want to mention the concept of a Docker file. So a Docker file is basically a text file that you create called dockerfile. It really just contains the same commands that you would use at the command line. Okay, think of it as like a shell script or a batch file or something, right? And so when we're creating an ASP NET Core app, we can have a Docker file in our project that basically says, hey, when you go to build this thing, this is the image I want you to start with, and then this is the main process I want you to run. This is the port number I want you to expose, so on, so on, so on, so on. All right, lots of stuff you can do in a Docker file. Again, all really well documented on the Docker website. But that's what we're going to use for ASP NET Core app. So for this, I'm going to switch over to Windows, and I'm going to go to Visual Studio. I got Visual Studio 2017 here, and so I'm going to go ahead and create a new project, and we'll go ASP NET Core application, and we'll go ahead and call this thing my Docker app. Okay. And we'll notice that when I go to create this in my sort of template chooser, I do actually have a checkbox down here that says enable Docker support. And so with Visual Studio now, you can actually get the Docker extensions for Visual Studio. So if that checkbox isn't perhaps showing up for you, go under extensions and updates and see if you got that there. But I also don't have to check this box. It's very easy to add Docker support to my application later on, and that's actually what I'm going to do here. So I'm not going to check this box. I'm just going to click OK, and we'll kind of see in a second why I'm doing that. But when we do add the Docker support ourselves, we'll get the same things as if we would have checked the box. All right? Okay, so here I am in my ASP.NET Core application. I've got my startup and my program CS and my app settings and all the things that you get sort of out of the box for the new app. And I'm going to make one change to this, which is I'm going to go to my home controller and my about action here. And what I'm going to do is, instead of just displaying this message that says you're on my about page, I'm going to actually modify this, because what I want to do is I want to print out some information about the OS that my app is actually running on, so I can prove that I'm, Visual Studio isn't doing some sort of trickery on me or something, right? That I'm actually running in my Docker container and not something else. So what I'll do here is I'm going to just run this. I could run this reverse proxy through IIS, or I could go ahead and just run it directly, which will use the Kestrel web host. And so I'm going to launch this, because really an ASP.NET Core app, and some of you may know this already, is really just a .NET Core console application with a main method. And when it runs that main method, it creates a web host, which usually is Kestrel, which is basically just an in-process web server, which listens for incoming requests and surfaces those to our application. So that's what I'm doing here, is I'm just running this thing. So I'm using, the .NET exe to run my DLL, which contains my main method, which is my startup. And so it's launched this thing. It's listening in localhost port 53085, launching up a web browser here. And then I should see my ASP.NET Core, basic template, which everybody's probably seen before. And I'm going to go to my About page, because I want to get that information where it prints out information about sort of what I'm running on. All right? And let's see here. Let me just launch that again. And so what we're going to do, once we confirm that this is good to go, is I'm going to go ahead and manually publish this to a location, and then go ahead and create a Docker image, and then run my container and do it that way first, before we look at what some of the built-in sort of fancy stuff that we're getting now in Visual Studio when it comes to support. All right? So I hadn't built the application yet, so I think what happened is it just sort of got ahead of itself a little bit there, and it wasn't ready. So, all right. So there's my application. That's what I was looking for. And so I'm going to go to my About page here. Notice in my console window, it's printing out all the stuff that we get because we've got logging turned on, and So here's my About page, and I'm running on Windows 10. Okay, that's what I expected. Running Kestrel, Windows 10. There's nothing Docker here yet, right? All right, so I'm going to close that guy, and I'm going to go ahead and just do a publish. Now, again, nothing special to Docker. I'm just going to publish to a folder. And so this will compile all my code. It'll generate my DLL. It'll actually do it in deployment mode instead of development. So it'll, take my right app settings and all those sorts of things. So I'm going to go to my desktop, and I'm going to create a new folder here just called publish. And I'm going to go ahead and publish to that location. So we'll let it do its thing here. And what I've actually got on my desktop is I've already created a Docker file. Okay, so here it is right here. And all this Docker file, and this is documented actually in the information about the image on Docker Hub, is I specified what image I want to use. So I want to use the Microsoft ASP NET Core 1.1 image. That's the one that just has the runtime stuff because I'm not doing a build server or anything. It's going to create a directory actually on the image. And then I'm going to copy everything from my current directory into that directory. Okay, so basically everything from my publish folder, I'm copying it into the image, right? And then my entry point is the main process for this container. So it's going to run the .NET executable with my Docker app DLL, which is what's in my publish folder over here. So this is the same stuff I would push up to my IIS application folder if I was deploying to IIS or something, but I have this here. So now what I'm going to do is I'm just going to take this Docker file and I'm going to copy it in here. Now, obviously, you can set up Visual Studio and things so that you have your Docker file as part of your project, and then when you publish, it copies it in there automatically, and you can set all that up. But for this demo, I'm just going to copy it in there, and then what I'm going to do is jump over here back to my command prompt, and I'm going to switch to my desktop publish directory, and then I'm going to go ahead and do a Docker build, because what I'm doing is basically building a new image, and it's going to use the information that's in that Docker file to build that image. And the Docker file says, which base image to use and so on and so on. All right, so we're going to build this thing, and we're going to give this thing a tag, and I'm going to actually call this BellJ My Docker App 1.0. Obviously, I can call this thing anything I want, but I happen to have something set up on Docker Hub that has that name, and I'm going to eventually want to push to there. So that's why I'm going to give it that name. I could change the name later too if I wanted to, but that's what I'm going to call it. All right, so here we go. And if we now take a look at our list of images, I have my ASP NET Core images on here. That D4W, by the way, is Docker for Windows, just an image that the system creates for me. And I've got my BellJ My Docker App 1.0 image. Okay, so if I've got an image, that should mean that I should be able to run, to launch a new container using that image. This is going to be running detached or sort of in the background, right? I'm just not interactive. I don't want a command prompt. I'm going to do a port here, and let's do, now Kestrel, because I did a publish, it's going to be listing on port 80 inside the container, but I'm going to expose that outside the container as port 8000. So that's the request I'm going to have to make to it to connect to it. And then, which image am I using? Oh, right, it's that BellJ My Docker App 1.0. All right, go baby. All right, so now I have something that should be running, and so if I just open up a web browser now, I should be able to go ahead and make a trip over to localhost, and then whatever port I decided to go with. So I said 8000, so we'll go localhost 8000. And now I'm actually browsing to my ASP.NET Core application, running in a Docker container on Linux, sitting, of course, but I'm on Windows, right? Because it's now my container, and I'm able to actually make requests to it and so forth, right? All right, cool. So let me go back over here now, and what I can do is let's take a look at again what's running. So now I can say, well, let's stop that guy, or hey, I could use the visual tool, right? So I could pop over here and we could fire up Kitematic again. Some people like command lines, some people like GUIs, some people use a little bit of both, depending on how you feel. But there it is. By the way, that name there, that unruffled Babbage, basically when Docker creates containers like this, it does have a container ID, but it also assigns sort of a random name to it. And sometimes if you've got lots of containers on your machine, it just makes things a little easier, so you're not just dealing with numbers and letters all the time. But that's sort of where that came from. So I can just click the X here, and what that'll do is stop and remove that container. Could have done that at the command line too. Could have stopped it, then removed it, but you know, pick what you like. All right, so the image is still there, but the container is not anymore. Okay, cool. Okay, so I could do it all without any help from Visual Studio, right? I could use Visual Studio, I could develop locally with IIS Express, Orchestral, publish, and then once I've published, I can now create a Docker image, copy my code onto that image. Now I can then take that image, I can push it up somewhere, run it somewhere else, do whatever I like. Or I could get some more help from Visual Studio. So what I'm going to do is let me flip back over to Visual Studio for a second here. And I'm going to actually right-click on my project, and I'm going to say Add Docker Support. What that's going to do is it's going to add a new project to my solution and also add a Docker file to my project. Now, the Docker file that it adds to my project is going to look pretty similar. Now, it's picking an image, it's copying stuff onto there. You know, the copy statement looks a little different just because it's a different place where Visual Studio is sort of putting the build products. But the entry point looks the same. Okay, so really similar. The project that it added is a Docker Compose project with Docker Compose files. And we don't have time in this webinar to talk anything about really Compose, but one of the things this allows you to do is I could have a Visual Studio solution with multiple projects, say a web project, and then a service, and then another service. And then when I run, I'm actually launching 3 containers, and those containers work together and talk to each other. So the container that's running my web app talks to the container that's running my web service, that talks to my other container that's running some other web service, and I can sort of compose those as a unit and then deploy them as a unit and so forth. In the longer virtual class that we'll have next month, we will be able to get more into composing containers together and using them sort of as a unit. Okay, but this is here, and so now what I can do is, if you notice up at the top, this changed from saying IIS Express or my app name to saying Docker. So now I can actually click Run here, and this will take a little while the very first time you do this, especially if it needs to sort of pull the image and things if it doesn't already have it. But it's going to go ahead and create an image. It's going to then create a container from that image and run it. And then Visual Studio is actually going to attach to it, so I can actually debug code that's in my container, right? And we'll see that work here in just a second. So I'm launching now, and we can look at our, I got interrupted there on a phone call. Hopefully we're going to be okay. There we go. All right, so there's our browser. And so now this is actually running in my Docker container, and I can prove it to myself because about Linux, yep, it's running in my container. I'm attached to it. So, okay, well, how about this? Go over to Home Controller, put a breakpoint here, go back to my browser, hit reload. And one of the things you'll notice, if you're actually running and debugging in a Docker container, the stuff actually works, but it may be just a little bit chunkier than what you're used to, just because obviously there's more pieces involved here. But usually you're willing to pay a little bit of that cost because now you're debugging and developing in an environment which is identical to what's going to end up in production. And so, you know, you do have to pay a little bit for that, but usually it's not too bad. So here I am, hit my breakpoint. I can hover over my variables and all that, same as what I'd expect. I can step through my code line by line. All that works really, really nice, even though this code is actually running in that Docker container, which is great. Okay, so I'm going to go ahead and stop that, and I want to do one other thing, is I want this Docker container that I've built here, this image, to be able to run somewhere else. I want to move it somewhere and go do it somewhere else. So I'm going to come back over here, and I'm going to actually push this image. So I'm going to say Docker, and I'm going to do a push here to Docker Hub. Now I'm specifying this name, but I've already on Docker Hub created this little public repository here, BellJ My Docker App. And under tags right now it's empty. So I do have to log in, so I run docker login, and it asks me for my username and password, which I think I should be good because I did that earlier. So now I can run a docker push and actually push this. And he says refer to a repository, Docker IO, LJ my Docker app. So now I'm actually pushing this up there. And you notice it says layer already exists for some of those layers because I have pushed other images up there that include the ASP NET Core base image. So it doesn't need to push all those layers. It just needs to push the ones that are different, right? And so now if I jump over here to Docker Hub and reload this page, I now have this image in my repository, right? LJ my Docker app 1.0, how big it is, and so forth. So now I can go over on my Mac here and I can say Docker pull and pull that image down from Docker Hub because it's public. I don't have to provide a password or anything. Or you know what? I'll just say Docker run. It's a background sort of thing. Port, let's use 8080 this time as my external port. And let's put in the name here, my Docker app 1.0. And it doesn't have that image locally. So it goes ahead and pulls that down, and then we'll create a container from that image, which will then be running here, and then I should be able to browse to it. So get a browser window, get ready to go, localhost, and I specified 8080. So we'll wait for this thing to do its thing, and then make a request. And of course, we should not see that this is running on Mac because it's running. It's a Linux container running on the Docker engine, which is running Linux. So regardless of where I deploy this or what I put it on, right, it's going to be the same. So there you go. Okay, pretty cool. All right. So we've got a few more minutes here, and so I want to talk about deployment a little bit. So let me go back over to, actually, let's go to AWS and Azure. So let me go to Azure first. And so what I'm going to do over here in Azure is we have support in here for being able to run containers. So think of this as sort of a Docker engine in the cloud, right? They have their own container registry, so I can push my images up to the Azure Container Registry. Or I can go ahead and say, well, let's go ahead and do container services. And I can go ahead and add a new one. And what I'm really creating here is a cluster of machines that are capable of running my container, right, or running my image. I get a choice of an orchestrator. So when we talk about running containers, container orchestration is all about doing that sort of life cycle management and health monitoring, right? So it's really easy to just create a container and then get it running on a host. As long as you've got the Docker engine there, you just pull the image and run the container, like I just did here on the Mac. But in a production environment, there are other things you've got to take into consideration and think about. You could have lots of containers running on lots of hosts, and then you need something that's going to monitor these things to see if they're healthy. And if one of them, dies, let's go ahead and just kill that one and start a new container on that instance or a new instance or something, right? And that's what orchestrators are good for. And there are lots of them that are out there, or several of them that are out there. And these orchestrators allow you to really think about what your server is going to be hosting. So you define your stuff, right, your image, but you're not concerned with where that image gets hosted or how much memory, or you let the orchestrator handle that, okay? And so you can pick from something like Docker Swarm or Kubernetes or DCOS, which is based on Mesos, or the Amazon EC2 stuff. And so if I'm in Azure, I actually, get to choose which orchestrator do you want to use. And how you interact with your cluster kind of depends on which orchestrator you picked. So if I picked Swarm, what's going to happen is there's going to be a master that I will connect to, and then on that master I basically will do the same sort of pull and run that I would do anywhere else, but now what I'm doing is I'm pulling that image and then running it on my cluster, right, across multiple instances, for example. If I choose a different orchestrator like DCOS, I get a nice GUI I can use to sort of accomplish the same sort of thing. But I'll say, let me create a my Docker app resource group here. Where do I want to put it? And then I also get to pick, okay, yeah, my Docker app. It's my DNS prefix, how I'm going to get to it, super admin. I need a public key, and then how many masters. Now, public key, I actually do happen to have because knew I was going to be doing this, one that I created. So just give me 1 second here, and I'm just going to grab it from here, because when you go to manage your cluster, you're going to have to actually SSH to that instance. And I'm going to show you where that's well documented and things, but we can go ahead and do this. And then what I want to show you, though, is you are going to get to a point where you're going to pick how many actual machine instances do I want running in this cluster. So you may say, well, I want 4 of them, and how big are they going to be? So how many cores, how much RAM, how big a drive, whatever. And so this way you can say, hey, I want to create a cluster of 5 instances, and I want at least 3 running at all times. Oh, and here's the container that I want to run on that cluster. And so what it'll then do is it will create, and I'm going to go ahead and actually do this because I want you to see, and maybe we'll look at it after the Q&A or something, perhaps, if we have time or whatever. But I can go ahead and create this guy, and it'll take a few minutes to do that, so we'll jump over somewhere else. But it'll actually create a load balancer and then load balance across those instances that are running my containers. So the 3 of them will be running, and then it'll distribute the load to those running instances. If one of them is determined to be unhealthy by the orchestrator, it'll be taken out of rotation, and then it'll grab one of those extra instances that are not being used and run the container on that one. So we always will have 3 running, where we've got 2 there just for freedom. When I go to do a deployment, I can deploy a new version of my container to my cluster, and I can actually do sort of a rolling deployment, where I can take one of those 2 instances that are not being used for anything, put the new stuff on there, those come online as the other 3 go off, right? And so I don't have any downtime. I can do sort of a, like I said, a rolling or like a blue-green type deployment where there's no downtime because I've got those resources to work with. And because these containers are lightweight, I can use very cheap instances. And in the case of like AWS, for example, I could even probably use free ones. Just have a lot of free ones instead of having 1 or 2 big, huge ones that I have to manage, right? So AWS is actually really similar. So I've actually got one already deployed here. So if I go to EC2 Container Service, I've created a cluster, this tree website cluster here, and I can get some monitoring on it. And this cluster then has 2 instances that are registered, and 1 is currently running. I could have 10 of them and have 5 running, or whatever you'd like. And I can define tasks. A task, basically, this has a container instance. So this is a task that's running on one of the instances in my cluster. So, for example, I could define a new task, and what this will allow me to do is then specify what container, because that's, and then an image, right? Give it a container name and an image. So this is I could pull that image from Docker Hub that I pushed up there and say, this is a new task, which is going to use this image, which is over here in Docker Hub, and please run this on one of my instances for me, or 10 of them, or whatever I like. And there's lots of other things you can configure in here. But you can really very easily, in a few minutes, create sort of a load-balanced cluster of machines, each of those machines running a container. And then you can roll deploy, and then you can monitor these things. And in this case, if I go over to my EC2 instances, I'll actually see the actual instances that are running Linux, that are running my containers. I've got other ones in here too, but there's one here and there's one here. These are running my containers. And if I actually go and look at load balancers, here's my load balancer that's set up that's going to load balance across my containers. And it does health checks. It checks every 5 seconds. What kind of health check does it do? It pings port 80 TCP. You can do more with this, obviously. And then you can see here's the instance that's currently assigned to this load balancer. I can remove it from the load balancer, but usually I let it handle it for me. If I just were to log into that SSH into that instance and then blow it up on purpose, the health monitor would pick up on that. It would bring the new instance up, put the container on that, the other one would go away. The load balancer would then remove the bad one, add the new one, distribute traffic to the new one. Azure would basically do the same thing. All right, we're deploying our container service right here, but we would see the same thing when we click in there. We would actually see the load balancer, we'd see our instances, we'd specify our containers. Now, how do you actually connect and deploy your containers? Really, really well documented. So in the Azure documentation here, it says how to, manage with DCOS, or manage with Kubernetes, or manage with Docker Swarm. And so in the case of Docker Swarm, how to connect and then be able to pull your image, basically deploy your image to your cluster and run that. talks about Docker Compose and other things, and so it works really well. Now, in Visual Studio, if you've got the Docker tools installed, and when I do my publish with my Docker-based application here, I can actually push it right from here. So I can say new profile, Azure App Service Linux, which is in preview, but we could do that. And then I can actually pick all my information right here. So what's my web app name, which subscription am I using, resource group, the container registry, and then be able to just push it right from here, which is pretty cool. And there's some good videos on doing this from the Build conference that happened. So if you go to channel9msdn.com and look at some of the videos from the Build conference and look at the ones that talk about Docker, you'll see a lot of great demos using Visual Studio and Docker together, and even some really fancy stuff with continuous integration, so that when you check changes into your GitHub, it'll automatically will pull from that, use a Docker container, do your build, and then create another image, which then pushes up to Azure, and all sorts of really great stuff. So again, some of that more involved things we'll get into, and we can have a full 2 days to talk about it. But for now, that's kind of really where we wanted to get. Okay, so sort of a whirlwind tour there, but as much as we can do in an hour without kind of leaving out important bits. So created some simple images, simple containers, deployed had SQL Server running in a Linux container on a Mac that we can use from Visual Studio when developing ASP.NET Core app on a Mac. Oh, it's a brave new world, right? You will get some emails after this webinar. You'll get a chance to sort of do an evaluation of what you liked about it and things like that, and what you didn't like maybe. We do listen to those. Those are important. You'll also get information about how you can get access to a recording of this. So if you want to watch this again at some point in the future, you will have the ability to do that. And like I mentioned, we currently have a virtual class planned for July 18 and 19. We don't have anything on the website right now, but it'll probably be there very soon, in the next day or so. But again, we can send you that information too, where you can get to that, or if you just go to winelect.com and do the drop down for training, you'll see the list of our publicly offered stuff, which will include that. Okay, so with that, I do want to have some time here for some questions, and so I'm going to look in the panel here and see if we've got some questions, and it looks like we do. So I'm going to start sort of working my way and see if we can get through some of these. All right, so just give me 1 second here to pull this off so I can read it. All right. Okay, first question. Let's see. All right, it's ASP.NET question. I've used Report Viewer for SSRS in Windows and ASP.NET Web Forms. Now that I've switched to ASP.NET Core, I do not find a SSRS Report Viewer solution for presenting my reports in the application. Any ideas? I don't have any specific information when it comes to the SSRS Report Viewer. However, one thing to keep in mind with ASP.NET Core is that ASP.NET Core, and this is the reason they sort of gave it a new name, is it's really something new from the ground up. And so ASP.NET Core does not include everything that full framework does. So I tell folks when they ask, we want to switch from ASP.NET MVC to Core, what are some things to look out for? And I say, well, if your ASP.NET MVC app is running on full framework and it's using third-party libraries and things, or your own code, that's using things that are in the full .NET framework but aren't available in Core, well, then that's a bit of an issue. You either have to see if you've got something equivalent that's provided for Core, or do your own thing or whatever. Now, you can run an ASP.NET Core application on top of full framework. Now, we don't have time to go too far into this, but I can just show one thing really quick here, which is in Visual Studio, when I say File, New Project, and I pick ASP.NET Core Web Application, I can choose ASP.NET Core on .NET Core or ASP.NET Core on full framework. If I choose ASP.NET Core on full framework, I get to use all the ASP.NET Core cool stuff, with middleware and services and all that, but I'm on top of the full .NET framework, so I have everything the full framework has. Now, that also means I can only run on Windows, but it gives me all my stuff. When I pick .NET Core, I'm cross-platform, but now I only have what's available in .NET Core, which is still evolving. With .NET Core 2, we're going to get a lot more stuff coming over from framework, but there will always be some stuff missing. So it may be that there's SSRS Report Viewer isn't available because it uses some things or something that's available only in core. You know, like I said, I don't have details on that specifically, but that might be what the issue is. Okay. Somebody said they also have a TI 994A. That's great. Yeah, I still have mine. It still works. Don't make them like they used to, right? Okay, so somebody said, I have an ASP NET Core Azure application using Azure SQL. How difficult would it be to repackage the system in Docker, and what are advantages and disadvantages of moving in that direction? So, all right, so let's say we've deployed to, and actually I have an application now in Azure that's based an ASP.NET Core app just running as an Azure web app, not Docker. To transition that to a Docker-based deployment would not be that difficult. Okay, and you kind of see we actually did that a little bit in Visual Studio just by right-clicking and saying Add Docker Support. I'm now sort of deploying into a Docker container, and then I can use that as my method of deployment. The advantages really to moving to that are mostly about two things. One, that your development environment is now identical to your production environment, which is always good. But then two, it gives you much more flexibility on the hosting side, because again, it goes back to that being able to treat the hardware just as sort of ephemeral resources that can come and go as you need them. And so the ability to set up a load balanced cluster is much easier. Things like updates. You don't have to worry about logging into your stuff. And well, if you're using Azure web apps, you might not need to do this either, but when you're installing container, it's bringing everything with it. So it's bringing the latest version of the OS and all the updates, and as long as you're using an up-to-date image, that image has that stuff on it. So when you go to deploy the next version of your app, you're deploying a new image. It carries not just a new version of your app, but also the updated, image with all the OS updates and everything else, which is really great. But just being able for your hardware to vary. So you could go into your cluster and say, hey, let's up the RAM or up the CPUs on all these instances, and now all your containers are running on these new, better instances. More flexibility, more options, more choices, right? When you use Docker Compose to sort of compose multiple ones together, then it really starts to get interesting, okay? Let's see what else we got here. I got a question that said, how do you know that 52 was the Docker process? Okay, so that's a good question. I did a command earlier where I said something like, here, let's look at this right here. And I sort of mentioned this, but it was kind of fast. So I have these images on here. So I've got this, actually, let's do the Docker PS. So I've got this Docker process running, this container that's running. And the container ID is this 2C0AEAB212A7. Okay. So let's say I want to stop this. So I could say docker stop, and I could type in 2C0AEAB, basically the container ID I got from the list. Or I could use the name, which in this case is sort of this big long one, which I have to sort of scroll over, but it's this docker compose 38218559. I could type that in too. Or I could just use the container ID, but I only have to type in enough of the container ID so it knows which one I'm talking about. So I could use 2C0. There's no other container IDs that start with 2C0, so it can do that. You know what? I can just type 2C. Or you know what? I can just type 2, because there's no other containers that are running that start with a 2. And then it can stop that container for me. So it's just kind of a nice little artifact of the Docker command line interface. If I want to do something with an image, it works the same way. There's all these image IDs. So if I wanted to remove an image, I could just say docker RMI, that's the command for removing an image, and then just specify the image ID, but I only need to specify enough, so 4 would be enough. I've got 2 here that start with 77 because these actually use the same image, but that's all that means. So when somebody said, how did he know the Docker process with 52? That was just the first 2 numbers of the container ID, okay? Can you map Windows directory into a Docker image? Yes, and actually that is what Visual Studio does. So when you're developing in Visual Studio, and when I did that example where I ran it and was able to debug in the Docker container, it's not creating a new modified image every time I click run. It basically created the image, the container's running, and then when I modify my application and click run again, it just can attach to the container that's already running. It doesn't have to create a new modified image and then launch a container from that, then attach to that new container, because the files for my application are not copied into the image every time. It's basically like a mapped drive. So the container that's running has, in effect, a map drive to somewhere else on my actual C drive, and then it's using the files from there. So the files are different, but I don't have to create a new image. That speeds up the whole process. So I left that part out, but there is one little thing you have to do. This is well documented, but before you can do that sort of debugging and everything in containers in Visual Studio, I do have to go into my Docker settings, and there's a shared drives options here. And so I checked the box there to allow my Docker containers to be able to do that sort of a thing. And so then Visual Studio handles setting that up for me. We could do things manually if we really wanted to, but I just have to have this so that way it can be able to do that. Okay. If you want to learn more about how Visual Studio and Docker interact with each other to allow debugging and everything and make it as efficient as possible, I would send you back to watching some of those build videos from last month, because there's some really good demos in there about that. If you're using Windows containers, can you set it up to use Windows authentication? Yes, you can. If it's an ASP.NET Core web app and you're trying to use Windows authentication, you're probably going to end up not using Kestrel. You may use something like Web Listener, which sits on top of HTTP sys, which of course is available and it's fine in Windows Server Core Nano. But then the Web Listener can support the Windows authentication as a mechanism for your ASP.NET Core app. Somebody said, so you deployed the code to Hub. I actually pushed my Docker image to Docker Hub. Yeah, my source code didn't go up there because when I did my publish and then I created a Docker image from my publish folder, it included my compiled application. So it included my www root and all that, but it didn't include all my source code. Okay, if I was checking into GitHub or something, I could have gone over to the Mac and Visual Studio on the Mac and then done a clone of my repo or whatever and rebuilt the application on the Mac because it's ASP.NET Core, so it's cross-platform. But yeah, I published my app and then took my publish output, created an image from that, then pushed that image into the Docker Hub. So then I pulled that down on the Mac and ran it over there, but I could also pull it from Azure or I could pull it from AWS to act as what I'm putting onto my cluster. Can you deploy Windows containers to Azure Container Services? That stuff is still sort of in progress. Specifically with ASP.NET Core apps, support for running ASP.NET Core apps on Windows containers is still sort of being worked on. So, there's some preview bits and stuff available, but that's kind of more of a watch this space as far as what's happening there. So, yeah. Somebody else, another question was, what is the cost of the virtual class? So let me just, for that, two things. One, I would just point you to the Wintellect website, and this is where you can see our list, our public schedule of what's upcoming. And so the prices vary depending on the duration and other things. So, for example, here's a using Redux with Angular 4. It's a 1 day. It's $4.99. So forth. So it will be up here soon, and you can do that. You can also, on the GitHub page, there's also an email address there too. So if you have additional questions as far as for upcoming webinars or other virtual training, you can feel free to use that as well. All right. Can we have a video recording of your presentation? Yep, sort of mentioned that. You'll get an email follow-up from this, and that will include information about how you can get access to that to be able to watch a recording of this in the future. Okay. How easy is it to configure HTTPS support for websites deployed in Docker containers, install certs, and so forth? It's actually really easy. It depends sort of on your hosting provider, where you're deploying to. But in the case of AWS, for example, here, this container that's running on my cluster, it's the load balancer that's actually handling my HTTPS for me. And so if I go to my load balancer, I do have two listeners here. One is HTTP and the other is HTTPS. So I can actually just upload my certificate here. So you can, if you've got it on IIS, you can export it from IIS or from your certificate provider, and then I can upload it here, and then this load balancer can actually use my certificate to handle HTTPS going to my cluster. Very similar for Azure as well. So here, look at my, for those of you that are still sticking around, this is my environment here in Container Services on Azure now, and so I've got my load balancer here, as well as my master that I would log into to deploy things and what have you. There's my load balancer right here. And Again, it's pretty well documented, but it's pretty easy here as well to be able to configure an endpoint that has HTTPS and be able to upload your certificate and so forth. But you typically let your load balancer handle that because you're going to be running multiple instances with containers. And so there's nothing you really need to do in your containers. You let your load balancer deal with that and then forward them onto your containers that are running Kestrel, probably. All right. We just got a couple more questions, so let's see if we can knock them out here. How much difference and change of difficulty is there in Dockerizing ASP.NET full framework apps using IIS? Not really any additional difficulty. If I say file new project and create an ASP.NET MVC app, for example, that runs on full framework, the Docker support works exactly the same. The only difference is you'd actually be just using a different image. So you'd be using one of the ASP.NET images that has the full framework stuff on it. But all the steps as far as managing your images, managing your containers, pushing, building, and then the deployment part is pretty much going to all be the same for a full framework. That's one of the advantages of Docker, right? It doesn't matter what's really on there. It's just a matter of which image do you want to use, what do you want to put on it, and then from that point forward, it's the same on all the platforms. Can you have multiple Docker images use port 80? Good question. No, it's the same issue as if you tried to have two applications, two websites in IIS both on port 80. Now, you can have two different containers on the same machine that are both listening on port 80. In other words, the containers themselves are on port 80. But what you do is when in your Docker file, for example, one container would expose its port 80 on a host port, say 8080. The other one would expose its port 80 on the host port of 8081 or something. So each container can do whatever it wants to do, but then when you push that, poke that stuff through to the host so that I can actually connect to the machine externally, I can't have them both going after the same host port because that's a problem. Okay, but a lot of times in the real world, you'd have a cluster with lots of different instances, and you'd only have one container per instance, and they're all listening on port 80, and it's no problem. You just have to coordinate that a little bit as far as the resources that are available on the host. Cool. Okay, I think we're going to stop there. Because we've kind of gone over here by almost 20 minutes, but I want to get as many questions there as we could. And so we'll go ahead and wrap it up. But it's been good. And again, kind of a whirlwind thing. I did put a few links again in the page here on the Docker, on the GitHub, sorry. So the SQL Server Docker images, the .NET Core Docker images, the runtime images. So all these images that are available on Docker Hub. The other place I would just refer you to real quick here is just go to docker.com and look through some of their tutorials and things. They tend to be laid out really, really well. And once you have a general feel for sort of what images are and what containers are, you can really make some good progress there. And then depending on your host, AWS or Azure both have really good documentation there too. So, all right, so thank you very much, and have a good rest of your week. All right, bye-bye.